Good evening, nerds. I'm Jeff. It's good to see you all again after a week off. It's good to be back in the chair. Thanks for understanding about taking a little break last Sunday night, just after a crazy week of snow that we had here in Chicago, and the workshop got to be kind of chaotic, and there was a lot of stuff going on. We're also total sidebar, pushing toward the very end of our Dungeons and Dragons campaign after the past 2 years. We had to plan a bank heist that's going pretty well, although we're about to get hosed, but that's just the way things go. In any case, thank you for understanding, but it's good to be back. As compared to last week when nothing got done, this week quite a bit's gotten done. Chris, you are officially a nerd. Hello. You and your HTML brackets. Hi, Thomas. Good to see you. Oh my gosh. Yes, I hope everyone's having a good week. I hope wherever you are, Chris. I know you're not that many miles from me. I hope you're enjoying the things melting out here as much as I am. Thomas, I know you're also in a cold part of the country. I hope things are melting there. We seem to finally maybe be out of the worst of the winter. Knock on all the wood. Yeah, let's get right into it. I have two things to share. One is this delicious. Where's my table view? There it is. Three Floyd's Barbarian Haze IPA. It's my beverage of choice tonight. Always curious if you're drinking something interesting. If not, no worries. No pressure. Not everybody's bag. It is my bag. It's very tasty. Very hazy. All right, so things happening this week in tiny moving light land. So I don't know if anyone caught so this is a little insider baseball, but God, it's over here. This is the cameras we normally look at when we start the stream. But this time I thought we would look at this view, which is slightly new. What's going on over here? So this is a thing, the physics of it I've been setting up basically for the past week. The camera setup I've been setting up for the past couple hours. So the view of it on stream is not going to be super great. More of a proof of concept than anything. But this is my little tiny working stage. And by working, I mean like working on, not necessarily that it's all working yet. That's 500 millimeters each on first electric and second electric, let's say, of Cookie's D3D truss design. Which is mounted with a couple of brackets that I designed to. This is actually, I don't want to, this camera, as you can probably already tell, is really crappy. This is actually a camera that I got myself, a webcam I got myself for Christmas from Menards for, I think, $17. Just as like I don't know. It was originally what I thought we would use to like look at the oscilloscope when we needed to look at it. And we still could, for sure. But as I was rigging up the truss today, and I thought, well, it'd be kind of fun if we could like have an actual camera view of that. And so here we are. So setting up like a working area with some truss has been sort of my work of the past week. The thing that slowed it down the most, to be perfectly honest, let's see, what camera are you going to be able to see this on? I think this one. It's going to be real dark, but you might be able to tell here that the mounting here, if I do better lights on it. Hey, Brokeboth, where are you? There you are. Hey, Brokeboth. I'm going to tell that one of the brackets mounting here is in this red and the other is in this gray. They're actually, you can't see this. They're two separate designs. And I'll just tell you about them because one of them is good and one of them is bad. The good one is just a little tiny, basically a little L bracket that extends up from an end mounting plate and hooks over sort of the shelf above it. Actually, you can kind of see it here. So this is the good one. It's a little L bracket. This goes up and over, hangs off the shelf. The red one does the same, except I feel like, ooh, frame drops for Thomas? Interesting. Well, we'll see what comes of that. I'll keep an eye on my frame rate down here as well. What I made a mistake of, and we might have done this the last time we were together on stream, was having a look at the length of this shelf that these are mounted under. And there's a sticker on the side of them, probably just out of camera here, that says that it's a 20-inch deep shelf. And I made the mistake of trusting that because though it is a 20-inch deep nominal shelf, it is in fact 19 3/4 inches. So I spent a long time designing a bracket that would account for a certain amount of overhang of the truss outside. Well, I guess the other way around. A certain amount of truss that was like the truss is inset within the shelf a little bit, so the brackets have to reach around and grab from the outside, when actually the truss is slightly longer than the shelf itself. In any case, this is all academic because the end goal has been a couple of electrics worth of truss just hanging out here, ready to put some things on, including, as Chris mentioned, one of the fun things I was playing around with this week like I say, it's been a busy week in the shop, kind of all over the place, right? Not without a ton of focus. And the thing we'll be working on tonight, which is some Neopixel truss warmers. Oh, hey, Dave, good to see you. Will be, yet another thing on the, the projects list. But this was something I've been working on. This is, in theory, the beginnings of a kabuki drop mechanism for this sort of ecosystem Demilight project. I don't know. It just seemed like a fun thing that I could whip together in an afternoon. And of course, it took a little bit more time than that. But as you can probably tell, it is the same sort of base of the Demilight that we've come to know and love with our new press fit hooks that we built on stream together at some point. They can snap together in a couple of orientations. And then really all I did was take the established size of the pan servo mount that I had been working on, basically the mechanism that is the pan servo in here, which is sort of a standard servo mount design that I've had for ages, and flipped it sideways and welded it in Fusion 360, right? Not physically welded, but just put it together into this base and lined it up so that the axis of rotation is sort of collinear in this axis and centered on this axis, right? So you have a couple of different options for where to mount this thing, right? So if you mount it, and this is, upside down from how you would probably hang a kabuki drop, but let's say you're looking up from underneath in this view, right? If you mount it like so, mount it like so and you have your pins actually clipped in, so it's not all cattywampus. Let's try that again. Do that, 1 and 2. There we go. If you mount it like so, your pipe, your kabuki drop pipe, would be coming straight out from this point here, from the servo point, right? In this situation, the drop is centered under the truss, which might be a thing you want to do, right? It's like this truss, the drop lives under, second electrics worth of truss or whatever. If you flip the points, which might be a little bit, oh, you know what's happening? I have just a little bit of flashing on this printed truss piece that's making it really clunky in that orientation. But I did just want to show, right, if you were to take the pins out, right, so instead of being sort of one in front of the other, if you orient them, let's make sure I get this right. Orient them 1 and 2, and we'll zoom out so actually things are visible. And you were to mount them, let's say, like so. Right now, if this is looking up again, looking from underneath the truss, now your axis of drop is on one edge of the truss, right? So this could be you could be concealing some lights that were hanging on, let's say, first electrics worth of truss by a drop that was coterminal with the front side. I guess you could also mount it, right, if now looked at from the top or the bottom, right, so it was sort of side-armed off like that. That'd be kind of fun, so your drop is hanging in front of the truss there. Chris says, printed without supports? Yeah, actually, yes. Printed sans supports. I think you're seeing, down in here, that overhang. Let me bring up the Fusion model and show you some thoughts I had on that, because for once I had some thoughts, and they worked out kind of well. Let's see, don't need the Arduino IDE. That's our truss warmer project. We'll get to that in a second here. Let me pull up my kabuki drop file. Kabuki drop file. Kabuki demo, kabuki servo mount. Here we go. I'll hide that guy too. Oh, let's see. Thomas says, finally got the fork of my mover back together, and I finished wiring the thing. First acetone weld together. Oh, interesting. Thomas, are you printing an ABS and doing acetone welds with that? An old, somebody I used to work with, tried to convince me that acetone welding and smoothing should not be a thing. And my counter argument to him, because I personally had never done it, was, well, lots of people do it, so therefore it works. And he's like, well, no, my chemist friend says it doesn't work. What are your opinions? In the meanwhile, let me show you here. So this is that servo mount we were just looking at, right? And you can tell I literally just chopped the bottom off a Demilight case design and took the pan servo, spun it around, and mounted it sideways like that. To get it to print better without supports, one thing I did is once I had, let me say this in the right order. Let me get one of our pan servos to compare it to. our pan servo mounts, as it were. By the way, I hope the audio is good. Or at least back to where it was. I think I sorted out the issues with the lav. So you notice we're back on not having a giant microphone in my face, which I quite like, especially now having like multiple places around to like scoot across to. So hopefully that sounds good. If it doesn't, let me know. We'll do something else. So this is the standard like pan servo mount that I've been using on the Demilight, right? So in reference to the 3D model there, right? That's the same orientation as is on that computer screen. So, but of course, this would print with this as the print bed, this down. So to get this to print nicely, one thing I did originally was just to, I thought about just extending this wall out to both sides, right? So that was just a nice clean bridge. But what I ended up doing is creating this little additional sort of span here, and then if you look underneath, the rest of that support is actually recessed by I think about 1 millimeter, and that's so that when we're printing up from the base, we're printing up, the first thing that we have to bridge is just this little like 3 millimeter bridge that stretches across here, and then once that's printed, that serves as a bridging point, a support point for printing this larger bridged section. And Prusa Slicer at least is pretty good about handling bridges. In a smart way, instead of like just trying to do like, say, diagonal infill over empty space. It's pretty smart. But doing things like this where you're minimizing, rather than trying to print this entire area as a bridge in one go, we start with sort of giving ourselves a Tetris-like support and then building outward from there. Hopefully that makes sense. Chris says bridging scares me. So Chris, I have a recommendation because frankly, on my old machine, which had substandard cooling, it did for me as well. Let's see, do I have pictures of this anywhere? I think if you go back to like it's probably in the video that I did on the 3D printer indicator light system. There's a little shot of a bridging torture test that I ran when we first got our Prusa Mini at work. Let me see if I can just quickly pull it up on here. I know you're looking at a different screen than I am, but I will get you there in a second. But the long story short, as I'm pulling this particular one up that I use, then there's dozens and dozens of bridging tests. But this one really built my confidence in the Prusa series specifically because I ended up with bridges up to 100 millimeters long with pretty decent quality. I mean, the very first bridge across is always going to be a little bit dicey, but the next layer looks better than those after that. So there's a little bit of sag in that first layer. I'm not having any success bringing it up, unfortunately, but if you go to Thingiverse, you go to Prusa printers, you search for bridging test. The one I found was it was like a spiral essentially. So on its like second layer, it printed like a 10 millimeter bridge, and then it went up a couple layers and did a 15 millimeter and a 20 millimeter, and sort of around in a spiral until I think the biggest one is 100 or 120 millimeters. It's a huge bridge. So that was really useful. Yeah, I encourage torture and calibration tests. The thing that one of the reasons that I'm like still over the moon about the Prusa Mini is not alone, its quality for its price, but I remember when we got it out of the box at work and printed out like the standard test cube, right? It's like cube is supposed to be 20 millimeters by 20 millimeters by 20 millimeters. And, on my printer out of the box, my old printer, it was like 19.8, 20.1, and 20.07. I was like, that's pretty darn good. The Prusa Mini was within the tolerance of my calipers, plus or minus like probably 20 mil. Call it like 20.02, 19.99. I was so impressed. So super impressed. Benchy, always good. Let's see. Oh, Thomas says, Thomas is doing most everything in ABS. ABS welding works great unless you don't actually have the two surfaces in contact. Yeah, that's the old like super glue problem, right? If you can't get the two things to actually touch, then they're just sort of sitting there with wet in between them, and that's no fun at all. Yes, where was I? Oh, Kabuki drop. Yes. So this is as far as the Kabuki drop mechanism has got, is printing out two of these, right? And the idea would be to, put two of these sort of collinear on a piece of truss, and then to put some kind of drop bar in between them. I actually did a little fusion mock-up of this as well, although it doesn't really have a 3D model associated with a drop bar. But just for those, I'm assuming many or most or all of you have run into a kabuki drop before. It's just a curtain that is rigged to fall in some way at a predefined cue. But in case that is a new idea to you, there are many different mechanical ways you could achieve that. But one of the ways that I am familiar with and have seen work, something's off with my patterning here. Probably because I've been updating this imported design, the kabuki drop mechanism design in the background, and not checking the rest of the assembly every time in between. But the gist is you would have a bar in between 2 points of rotation with these little fingers or flanges sort of welded onto it. I say welded, this would be a 3D printed thing. I guess it could be like a copper tube with additional 3D printed parts on it or something like that. But the operation that I have seen for this style of mechanism is, you have your long tube with essentially fingers pointing up, and the top of your soft goods, which often is a grommeted surface, you would have a line strung through each of those grommets, right? So if your curtain's here, it has a bunch of different grommets on it. You have, and sometimes it's just like tie line or like 1/4 inch black rope, just like loops daisy chained through all of those. You hang the interstitials of those rope loops onto the hooks of your fingers, so your curtain is hanging off of your, wow, really overexposed there, huh? Your curtain is hanging off your fingers like so, and then you have some mechanism that allows the pipe that those fingers are mounted on to swivel downward, and the curtain slips off and falls, right? So fingers pointing up, curtain installed at predefined cue, fingers rotate down, curtain falls off. The ways that I have seen this done are numerous. When I was at Looking Glass, the production I interned on, the first production of Looking Glass Alice, has no spoilers. There's a big kabuki drop moment in that show. For those of you who are Chicago-based, when Looking Glass Alice comes back, and I assume it's the first thing they're going to do when things come back. If you haven't seen it, amazing show. That was actually 7 separate kabuki drops that were triggered at the same time, and they were exactly this mechanism, right? Fingers pointing up, curtain hooks over the top of those, things revolve down. The way that this was actuated was actually just mechanical. Basically, if my wrist is our point of rotation that we've been playing with, hanging off of this side where my forearm is was a big iron weight on each of these kabuki drops, just to counterbalance the weight of the curtain, right? So a very long lever arm with maybe a 20 or 30 pound iron weight counterbalances the weight of the curtain, which is almost, but not exactly, under the center of mass of the pipe. And so to get this to fall, 7 strong people would grab ropes attached to a lever arm on one part of the pipe over here and pull down. So the whole pipe rotates. You see, lift the weight up, you allow the curtain to tip off, and then the curtain just falls. Let's see. Dave says double kabuki drop. Curtain starts bundled and out of view. First drop. First drop drops the curtain into view. Second drop gets the whole curtain down. Yes, we did one of those as a prototype at Shakespeare, and I don't think it made it in the show for artistic reasons. But yeah, super cool. Like it appears and then it's gone. That's not true. We did it in Hamlet. But they weren't full stage. Like the kabuki drops were like 3 feet wide. Like there were, I think, 5 3-foot panels. So I don't think of it as a kabuki curtain. It was more of an effect. The one I was thinking of that we cut was in Midsummer, I think. So that's one way you could do a kabuki drop, and that's the way that like I'm illustrating here is like, here's the fingers in their tipped down position and our beautiful red curtain that's about to fall to the floor. The other way that I have, the 2 other ways I've seen this done, and now I'm just going to ramble, but some really cool technology goes into these. Chris's kabuki banners, yeah, exactly. Yeah, I was like, we want it to appear, and then I think when Polonius busts out from behind the arras, like instead of him ripping one down, they just like kabuki, like he shouts and a kabuki banner, one of 5 just falls to the floor and it reveals him. That was kind of cool. And then later, I think they all fall when Ophelia is drowning. I think that was right. That feels like about 1,000 years ago. I think it was 2 years, maybe. When Looking Glass Alice came back, this similar mechanism, except instead of having ropes that were pulled, there was a pin at one end of the set of pipe that sort of latched into place to prevent the weight of the curtain from pulling the fingers over, and a solenoid, when energized, would pull that pin and allow the curtain to fall. And the trick ended up being that there is, of necessity, a lot of force, a lot of sort of side force on this pin as it interacts with the pipe. So they ended up investing in some really nice, basically a linear bearing to sit between the solenoid and that pinpoint, so that as the pin is trying to be pulled, it's under a lot of lateral force, but it's sitting inside this very nice linear bearing, so it's still able to pull out and allow the fingers to tip. That was pretty cool. One of the last shows I did at Shakespeare was Six, the musical, and for that, they actually purchased this UK-based kabuki drop system, which was little boxes, each with a little solenoid in them, basically, and that attached to a ring or whatever on the top of your curtain, and you strung, I think, power con between each of them, and you had a control box that energized them, and they all just dropped. And that was it. And they were just really, really well-engineered boxes with great little bearings inside of them. That system was expensive. I wanted like in the several $1,000s for a box of 6 of these things and I think one manual press button, but it worked every single time. You could build a thing that has a little solenoid that goes dink, but for a thing that is gonna work every single time, and it's willing to work well enough that a company is willing to put their name on it, which is bold. We just bought the thing, and I have no regrets. So that was very cool. I'm just rambling about kabuki drops now. I think these things turned out so adorably, and they kind of are along the theme, right, of what we were talking about the last time that we were on stream a couple weeks ago, which is the idea of slicing and dicing these designs and remixing them to make new, interesting things. So this is just 2 pieces of the Demilight project that got sliced together in a new orientation, and now they're going to be a kabuki drop, I think. But, yeah. That's I think what's been going on in the workshop this week. What we're gonna work on tonight is some more sort of remixy kind of stuff. It occurred to me actually as I was prepping for this evening, is that I really just sliced the bottom off of the Demilight and not thinking about what you could do with it. It would have made a lot more sense to allow room for a control board inside of this base, right? Which there is not currently. I filled in the hole in the cutout where you would put the Phoenix connectors to come out. So that was a little bit silly. But probably what I would do is, once these are, mounted, 2 of them on a pipe, which now I gotta restore the mounting hardware that I moved around for the sake of demo earlier. And I know this camera view isn't the best, but I'm enjoying it. I'm enjoying having it, I suppose. And we'll make it better over time. I mean, at some point, if we end up doing actual show programming, we'll move one of the good cameras over to point over here, and the little camera that looks at my face on the computer doesn't need to be high quality or anything. Yeah, Kabuki 1.0, exactly, Chris. What was I saying? Oh, the thing that we're working on tonight, right, is as I was looking at this camera when I got it running a couple hours ago, and it's just, it's not a very good camera. It has very little autofocus. It has very poor exposure. It's kind of grainy. And I was like, well, it would be nice to have some more light under here, and that jives with a thought I was having the other day, which is, well, these trusses are just, they're just so cute. And they're reasonably strong. I like this as a system. This is, I think I've said it before on stream. I think you all the regulars I see there in the chat, you all know this is Cookie's system. This is not my design. If there's not a link still in the description of this video that's a holdover, you can find links to that on the website, jeff.glass/Demilight, or go to Prusa Printers and search D3D Truss. I thought it would be super fun to have some little LED, maybe Neopixel style truss warmers to go inside these guys so we could light it up with some color and see a little bit better what's going on in here. So that's what we're going to play with tonight, is some more Neopixel control and some more 3D printing and design to maybe get these things lighting up in RGB. So that's the goal. Dave says Kabuki Fire. I guess, Chris, you might actually know, how expensive is a sheet of flash paper these days? Because I think that would be, you could have a, although if you're going to light your Kabuki curtain on fire, do you really need to Kabuki it, right? Could you just burn it up? It sort of gives new meaning to the idea of a fire curtain. Very good. Where do we start with this Neopixel project, I wonder? I think let's start with some Neopixels. That seems reasonable. And I think we're going to, the sake of having DMX control, I'm just going to use a standard 0.95 control board to drive it. Let's use this one, which I know has the bootloader, but no actual code on it yet. So that may make things easier. And what I think I'm going to do as far as mounting, and I know I'm overusing this camera view, but I'm just so tickled by it. What I think I'm going to do is start by like mounting, say, this one here. And we'll probably just, zip tie a control board up here to play with. And then once that works, we can do another one with some longer wires and drive it off this end. I guess we'll just daisy chain out of the end of the Neopixels. That'll be good. And sort of do one truss at a time. And then we can decide if we want to do separate control boards for each truss. We'll get there when we get there. But yeah, first let's get some wire on these Neopixels. Ooh, Chris says they make flash paper glue to glue multiple pieces of flash paper together. That's cool. We do have a little local magic shop like 2 blocks away down the corner here. I don't know if it's open at the moment for like, although I hope they are. I thought I saw a thing that said they were like closed indefinitely, but maybe indefinitely has ended. Chris is printing cable clips. Oh, that's a fun idea. Yeah, the clip design that I'm using for like the little clamps is pretty nice. Like, has turned out to be a pretty decent form factor. So I could probably reuse that at least as like a guide for. Let's see. I'll do this with stranded wire. That'll be fine. Will it be fine? Maybe we'll do solid core for this, and we can do stranded for the longer run down to the other end of the truss. Hey, here's a little tummy cam for y'all who've been missing it for the past couple of weeks. Oh, there we go. All right, big spool. Cut off a nice long pair of 20 gauge bell wire. Set that to the side. And we'll get to work on this. Let's see. Chris's Magic Ink is a nice magic shop. Which one is that, Chris? So the one I'm thinking of is like on Lawrence, right at. This is Chicago talk for those who don't live in the city. I apologize, but I do love the city. Just between Western and Ashland on Damon. I'm not quite sure if that's the same one you're thinking. I actually don't know what its name is. You know what's a really cool place? As long as we're doing Chicago plugs, here's a place I should plug. Actually, full disclosure, run by a friend and former theater electrician. God, what is it called? The magic venue that is also, like, there's the hidden behind the fake laundry over on Clark Street. The Magic Store? What is that called? Chris, maybe you can help me out here. In any case, there is a magic venue in town that's run by an old friend of mine who was a theater electrician and is a quite a skilled magician. One of the cool things about it is to get into it. It looks from the outside, other than a sort of subtle sign, it looks like a laundry, and in fact, it's on the site. Magic Lounge, yes, Chicago Magic Lounge. Thank you, Chris. It looks like an old, laundromat, and you walk in, and it's clearly like a set piece of a laundromat with like three washing machines and dryers, and there's a security person, a bouncer, essentially there, who asks you to, for the password to figure out how to get in, and you say the magic word, and a washing machine dryer combo like opens up and is actually a secret door and lets you into this super cool venue, which is a 3-theater magic venue, right? There's like a large theater, there's a small theater in the back for like up close and personal intimate magic, and then they'll do magic for you at the bar, because most, if not all, of their bartenders are also magicians, or magic practitioners or what have you. It's just a super cool, evocative well thought through kind of a place. So I know it is not open at the moment. It's all about intimacy and being close to other people and all this stuff. But when things come back again like that, for those in Chicago, or frankly those who are passing through Chicago, that is a super duper fun place to visit. The lighting package I have some opinions about, but what else is new? You don't always get a choice. Yeah, super cool place. All right, so that's our ground, our power. We'll need our data input. Let me grab a little bit more bell wire here. Yeah, Chris, that is a super nifty venue. I just love the immersiveness of like from the moment, even just getting into it is an experience, right? They're bringing you into this kind of like, it's fun, it's interesting, but it's also like it's a little bit tongue-in-cheek, like all magic is. It asks you to say, if you're going to come in here, then you gotta kind of play along, right? You gotta say the password. You gotta walk through the washing machine, and once you're in, then you're in, and now we're all in the same space together. And their bar is also really good. So yeah, Chicago Magic Lounge, super cool place to check out. When checking things out is a thing we can do again. Ooh, yes, Chris, I have been to that, but the secret spy bar, whatever it is, the spy joint. Mary and I went on Mary, my wife, who it will not. I don't know if she'll be popping her head in tonight. I suspect she won't. But she says hello to all you good people. We went to a trip to Milwaukee a couple years ago. Went to Safe House. Yes, Chris, thank you for being our reference librarian as always. Yeah, another place with like a really interesting aesthetic that it asks you to buy into, which I think is a really fun idea. Okay, so there is our Neopixel star. And to mount it, actually, something I prepared beforehand was these little guys, which I also can show you. I had a little bit of fun doing a 3D design for these. This is a really simple design. So this is oops. There we go. The inside of a piece of truss from Cookie's D3D truss design, which goes together with a couple of either M4 or, in the Imperial system, number 6 screws, right? They're sort of meant to bolt together with a screw and a wing bolt. And I figured, well, why not just hook our truss warmers into that same system? So what I've got here is just, it's just this little piece of 3D printed plastic, which hopefully will mount to those same two holes. And it's occurring to me that one of the things that I should do, because these just printed a couple hours ago, is check that they actually fit within the truss system, because if they don't, we should take a stack and redesign them and get them printing, because I think they take like 7 or 8 minutes a piece to print. So let's do that real quick, and then we'll come back to assembling this system. Really just check sizing. Yeah, so the idea is, here's our truss. They would sit sort of just inside there. I'm not even going to assemble them all the way, but I am going to grab a couple of M4 bolts. Where's my M4 hardware bucket? I had it out earlier, which means I've misplaced it, of course. If I can't find my M4 set, I do know where my number 6 hardware is. Oh, is it this? Ah, yes. There we go. M4 hardware. Oops. Just yank the cable out of my headphones. Downside is you have to take the truss apart to install them. Yeah, you're not wrong, Chris. Like, the other thing I considered and could certainly do, right, is make them another like clip-on module or even like a friction fit module. So they could either, clip to the interior of the truss somewhere here, or like it could almost be like a press fit. Although the diagonals are a little funky because they all have these members as well to contend with. So yeah, so not necessarily like the most field installable system, but they also it was like the easiest thing I could think of to just sort of get us going with. But that's a very fair point. Just gonna check fitment here before we get too much further. In fact, I can just do this on the outside of the truss. Yes, that would be fine. We'll put a wing nut through there, and of course this would be on the inside of the truss. I guess it doesn't have to be, but I've been imagining it on the inside of the truss. All right, so that's that's encouraging, considering that I drafted it that way. Thomas may have had a slight goof. Order of operations is important. Thomas, I know this. I know this well. I think it was you, among other people, who encouraged me to write up the order of assembly for the Demilights when I, am needing to install them. And that has saved my, long before there were instructions online, that saved my buns many a time for being like, oh no, you can't screw that servo in until you've put the yoke on, because if you do, you can't access the servo or whatever. So I'm just going to use a little bit of VHB tape here. One of my favorite quick stick tools to secure this Neopixel star in place. Let's see, diagonal mount between the main bars allows you to place them further stage left or stage right if needed. Chris, I think that is generally true. The trick is the diagonal members, right? So, I see. If we were to go on these diagonal mount between the main bars. So we could go, looked at in this view, we could go sort of top member here and bottom member here. The problem is these diagonals start getting in the way really quick. And I have not verified this. I feel like the aspect ratio, well, maybe that's not true. I would say the aspect ratio of member diameter to spacing, like chord diameter to chord spacing, is thicker on these than on full-size standard truss. But actually looking at it again, I'm not 100% sure that's true. But like if you were to try and put something here, where this is, you could go to here, but it couldn't slide very much in either direction before it starts interacting with this. Might be better to do something that was two lateral bars, like a sort of a tetromino piece that hung it down into the middle, because it could slide on these rails. That might be kind of interesting. Yeah, that might be kind of fun. Let me put tape away there. And let's get, so that's going to be our little truss module there. What I think we'll probably do for playing around this' sake is assemble and test this on a little piece of truss on the workbench, and then we'll solder it into what I've been thinking of in my mind is the micro stage. That's such a highfalutin name for what is some 3D prints under a Container Store bit of shelving, but it kind of cracks me up. Thomas has updates on order of operations. Thomas says, all right, I started the LED/heatsink which blocks all the soldering I have to do and hide in the fork. Theoretically, I can still do it, but gonna be tight. Do I want to desolder all these wires? No, I have some regrets. Yeah, it's like darned if you do, darned if you don't, right? Like that is a tricky place to be stuck. It's like when you solder all of your connections onto your XLR connector and then realize that you didn't put the back shell on. If you take them all off, do you take them all off again? Do you do some XLR crimes? There's no good answers there. All right, let's put our programming header in here. So these are still, I've not done any further work. I put on the 0.96 boards that we were developing the troubleshot for. These are still 0.95 boards with the TX and RX reversed. For some reason, I think I mentioned this last week, and I'm sure all of you out there can sort of appreciate, these days with the world, right? It is often hard to get the brain to do exactly what you want it to do when you want it to do, and in particular, being back at work full time has been a real interesting, what do I have energy for this week? So this week I've had a ton of energy for this kind of project for some reason. You can tell the arm that holds this camera just a little wobbly. This was super exciting, jammed on that for a while, and I just have not been able to get my brain in gear to open Eagle and work on the 9.6 PCBs. I just can't quite, I don't know. And I think that's partly because that kind of, circuiting and problem solving is kind of what we've been doing. We've been troubleshooting this Turing light plot that we have coming into the museum, which has been a lot of fun. That's my core competency, is troubleshooting light plots at this point. But the problem solving muscles feel very similar to circuit layout in a funny way. And so because this is a hobby and because I have the luxury of not working on things when I don't want to, I just haven't. So this is still, all that to say, this is still a 0.95 board, so we'll use our little programming adapter that has TX and RX on the serial port switched until I can get my butt in gear and finally get the 0.96 circuits sorted out and on their way. Chris is at a similar point with Project's printer enclosure. Yeah, It's so, listen, I don't know if anyone enjoys thinking about thinking. I kind of do. My former roommate, not my wife, my former roommate definitely did. But it is kind of interesting to, like, you know, sometimes sit back and be like, huh, interesting brain, interesting what you're doing today. And yeah, sometimes it's not just like about a lack of energy or focus or follow through. It's just like, oh, I just can't do that today. And it is a real like luxury and privilege to have those be things. It's like, okay, well, this is a hobby, and you know, it's okay for me to not make progress in this area today or in any area. You know, save that energy for like, oh, I do have to do work. Like, I do have to go and earn money and pay rent and things. But it's one of the things I think that keeps a hobby feeling like a hobby, right? Is the ability to say, I do want to work on this today because it's going to energize me, not I have to work on this today because I, for some reason, feel like I have to. So there's our 0.95 board. Let's get the Neopixel wired up to it. So we've got 3 connectors, we got ground. So this will actually be quite nice and hopefully easy because we now have, as of 0.95, if you recall, we have some ancillary data and power pins to work with. On the previous version of the board, right? I think when we were troubleshooting we were doing that Neopixel light originally, we had to tap into the dimmed line that was going to the LED driver. But for this one, I'm just going to use pin, let's call it A4, and I have ground and power actually right next to it there. That'll be really easy to play with. And I included those power and ground connections. Honestly, the reason I did A4 and what the Arduino environment would call pins A4 and A5 is because they're the ATmega 32/8 I2C pins, which is what I'm using for the Pocket RDM project to drive those little screens. Remember that project? That yet another thing on the workbench there. The idea being that you could, you know, in theory, hook one of them up to a base Demilight board and have a little remote display or a little local display, I guess, on your tiny moving light. Let's see here, just get those soldered in without bridging them to the programming header. Hopefully. Not doing the cleanest job of soldering those, but that'll be serviceable. Just trim those off there. Let's see, Thomas says his club he was in had an EOS augmented session. Ooh. And dropped a 1.6 gig STL file in and crashed it. Yeah, you know, I can't exactly fault ETC for that one. Right, that seems like a little bit beyond. I wonder if it's a limitation. Did you have any success, Thomas? Is it a limitation of the augmented engine, or Augment 3D, or however we're saying it these days? Or like, you know, if you had a computer with a bunch of RAM that could swallow that model, if it would perform a little bit better. All right, well, there's our Neopixel wired up to this board, hopefully in a successful way. Let's load up some test code and see if we can't get that working. I'm just going to pull up like an example bit of code from the Arduino IDE to start with, I think. Let's pull up some examples. We'll just use the Adafruit Neopixel library. How about a RGBW strand test? That sounds quite good. We've got 7 LEDs on our start. I can hide that for a sec. Brightness 50 is fine. Begin shut up, so brightness. Fill with the various colors. Our red, green, blue, white, rainbow. Gonna do some effects are built into this test here. Which pin on the Arduino is connected to the Neopixels? I wonder if this is critical. But for me, it's going to be, I believe, on pin A5, what we would call A5. Oh, we'll need to save it as a new thing. Sure, this will be, yeah, okay, just save it as that. 7 pixels, bright. All right, in theory, that is correct. Let us plug in our programmer here, and I'll need to plug it in through our crossover adapter that we built last time, and I'll want to make sure that our ground lines up. So ground on the programmer is there, ground on this side I labeled in a big white label, and ground on here is here. Okay, so this plugs in like so. And I can tell I have some power. Neopixel's lighting up there. Let us see if I can Pro or Pro Mini upload. Compiling. Uploading. Oh, it feels so good. Remember all the struggling we did a couple weeks ago to like try and get that to work? Ooh, there we go. Yeah, here, once again, let's turn the brightness down so we can see a little bit better what's happening in here. We got some twinklies. Something, I don't know if that's exactly what it's supposed to be doing. Oh, you know what it is? It's because this program is meant to be for RGBW, and these pixels, of course, are RGB. So that's what would make it look strange. Let's see. I'll bet strand test instead of RGBW strand test is quite good. It's probably the same thing, but not RGBW. All right, let's save this as something, and we'll upload that. Let's try this again. I'm gonna say this doesn't look like solid colors followed by a rainbow. There we go. Let's see if this is a little bit better. Yes, red, green, blue, twinkle, 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 red, 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 twinkle, 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 blue, 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 twinkle, 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 and a rainbow. Yeah, that's awesome. Oh my goodness. Thomas is responding to me saying, well, maybe if you had a bigger computer. No, Thomas is laying it down. 64 gigs of RAM, 12 threads, and a dedicated GPU. Use all the RAM generating the 35 million polygons inside Blender. Wow. Yeah, that, I really, again, I can't fault Augment. Do you say, question for the group, do you say Augment 3D or Augmented? I have heard both, and I think I have said both, even this evening. I'm just curious I don't know if there's a canonical, I'm assuming ETC like announces it, when they announce it, like, introducing, but what do you actually say? Just curious. All right, well, now that we have this wired up, let's get it playing nicely with some DMX. Thomas says augmented is correct. Okay, I can get behind that. I think it's less of a mouthful than Augment 3D for sure. Let us, you know what would be a good place to start as far as code is, we wrote some code that had a Demilight and a Neopixels in it. Demilight Neopixel. That was back in December. Holy cow. December, that was exactly 2 months ago. And it looks like I did the same thing. I based this on one of those Neopixel examples. We'll say 7 pins. Ooh, we can hide that again so we can see a little bit of code. Pixels.begin. We set the various colors. Oh, did this use? This is not really This is not really a Demilight with a Neopixel. It's just the Neopixel demo. That's not quite what I want. Let's see. DMX Master Multi-Test, DMX Test Neopixel. Maybe this is it. Let's see. Ooh, this one has the servo library, Adafruit, and Conceptonetics. That's a good sign. LED pin. Let's see. Am I reusing LED pin? No, I sort of spliced these two examples together. Let's see. Landy also. Let's see. Hi, Landy. Nice to see you. Go with augmented. Yeah, I feel like Augment 3D is just, although the problem is then, right, of course, if you tell someone, oh, it's this program, it's called Augmented, and you go and search, I wonder if you searched Augmented Lighting Program, do you get ETC's program? Because that kind of solves that problem, right? So this is our start address 1, get channel value 10, 11, and 12. All right, so let's make this RGB are going to be 10, DMX values 1, 2, and 3. So we'll say that DMX values 1, 2, and 3 are going to be our RGB components here. And I'm going to leave the slave channels in as parameters 4 and 5. Sorry, the servo channels in, because I think that might be something interesting to play with later. And we'll just make sure that it all still compiles at the end of the day. But let's upload that, and then we'll need to get a DMX source going. Let's see. Augmented apparently gives you a warning with more than 300,000 triangles, says Thomas. That seems like a reasonable thing. Certainly Fusion throws up when you try and do any mesh conversions with more than like 30,000 triangles, so it's not... 300,000 seems like a pretty fair amount to limit you to. All right, so this now in theory is a DMX responsive Neopixel device. So let's test that out before we install it in some Truss. How do we want to do that? I haven't really, so I think I mentioned, I don't even know if it's still on the workbench here. I finally purchased a proper USB, DMX little dongle, and specifically one that had RDM capabilities when I was doing some more troubleshooting on the RDM part of the JDMX library, and it doesn't work. The RDM is totally busted. Which is a bummer. Now, thankfully, and maybe causally, it wasn't the most expensive gateway out there. I was just so kind of bummed. But it reminds me, the other source of DMX I have is one of these cheapy 612 channel DMX controllers here. Let's use that as a DMX source. Let's see if I have close at hand a 3-pin XLR male to 4-pin Phoenix connector adapter. I suspect I do, yes. In fact, I have one just here. But that one doesn't have power injection already on it, so let's use something like that guy to get power into it. And do I have just a basic jumper? Ooh, actually, I have a second one here. Oh, that's not the right connector. I think maybe we'll just add some power connectors to this 3-pin jumper, because that's going to be a useful thing in general. Right, so for those who are joining us this evening for the first time, and Landy, I'm not sure if I have seen you in the chat before. You may have been here for weeks and weeks and weeks and just popping in because I'm saying augmented wrong, and that's a perfectly valid thing to do, but if it's your first night, hi, it's nice to see you. For those who may be just joining us for the first time, in chat or no, the miniature DMX moving light project that Demilight has sort of standardized around this 4-position 3.54 millimeter spacings, right? So 150 mil spacing Phoenix connector. So to plug in DMX and power to this board, which is going to be our Neopixel truss warmer, I'm going to plug in this 3-pin XLR connector to my cheapy, DJ-style light board, and I have this 4-pin connector here, which is DMX, but it also is going to provide power. And to do that, I'm going to add a couple of power wires into this same connector here, using my trusty old 3/16 flathead screwdriver. Landy says, stop by a couple times, and Mini's like, it's super interesting, need some eventually. Yeah, for sure. Yeah, I can't remember if this was, I think it was shortly before the last stream that actually did. I posted something about I don't know if anyone else is a part of the Everything Stage Lighting group on Facebook. It really is everything stage lighting. And of course, I come at this from a nonprofit theater and now a museum background, but a huge part of performance and live lighting, of course, is driven by concerts and rock and roll and DJ world and things. It's all of those things combined, and then some, and manufacturers and products and all these things. Anyway, I posted something with a little tiny light, and there was some really nice response, which is really quite nice. So, and there were a few people who subscribed from that, so maybe some of them are here checking it out as well. Yeah, I still really don't know what one of the things I have said as an end goal, right, is to maybe sell a few of these little control boards, not so much to like make a business or a profit off of it, just because like I think that is for a nerd who's interested in having little tiny moving lights. That I think is probably the biggest barrier to entry, right? The 3D printable parts are pretty printable. The assembly of the servos and other things is meant to be not terribly complicated, but what makes it miniature is the assembled PCB. And I think one of the easiest ways to get those into people's hands is just to like put them on Tindy or something, and sell a few, which is like nerd Etsy, pretty much. Demilight showed up in a Christmas light group on Facebook. Oh, that's fun. Oh, that's so cool, Chris. That actually, I'm really chuffed to hear that. Like, it's cool to know that it's popping up in some other places around. It's funny too, right? Because this is like I hope this doesn't go up in smoke. Maybe I will just unplug it from the light board until I know it's not going to. All right, well, that lit up briefly and then turned off, which I hope is good. So now, in theory, if I plug... Did I reprogram this board with the new code we were just looking at? I don't think we did. I think that's going to have to be the first step, right, is to actually put the code on the thing. Let's get that uploading. Hopefully that works. Yes, there we go. Writing, reading, good. All right, unplug the programmer, turn power back on, come back to the table. Oop, turn the light board on. Hey, there we go. Yeah, all right, here, let me turn this off so we can see a little better. Table focus. Muted? Thank you. When did I mute myself? How long have I been muted? Well, that's Landy. You've been here before. I'm sure you already know, but that's pretty standard. Is somehow becoming muted. I wonder how that happened. I must have bumped something. Maybe I bumped it. Maybe when I unplugged the light board, I put the yes, Thomas. Yes, you can always call the bat phone. Let's see. Last camera change. I guess what I'm most worried about is like, does one of the buttons for change? Sorry, this could be chaos. One of the buttons for changing cameras also mute me, like a Russian roulette stream deck. I guess we'll find out. Thank you as always. Yeah, Thomas. Yeah, next time you can just. What's funny is on the new stage view, the bat phone is very prominently featured. Here's all right. It's not like I don't have enough projects, but wouldn't it be fun if, right, make the rotary dial on the phone control the lights somehow, like recall a preset or an effect for the lights by dialing the rotary dial? I have too many projects already. I don't need to do that, but it's a fun idea. So what we missed in all the muted excitement, really muted excitement, is this works, right? I have 3 channels of control, RGB, and they're working there. It's not super bright because the code is limiting it to 50% brightness. I think because this is just based on one of the Adafruit examples, and I think the assumption is that, oh, maybe it's not. Maybe I'm not even setting the brightness. Set all color. Maybe we should set the brightness then. Let's go into our other demo and just steal some code here. Let's see. Set brightness is the function we want to call. Let's go in here, and in our initialization function, we will just call set brightness to full. And that is pixels is the name of our Neopixels object. And let's re-upload that to the board. focus the lights on the phone when it rings. Ooh, yes, Chris, this is not the first time that you've had a really nifty idea for like making the lights, oh, you're over here now, making the lights more interactive in a way, right? Like when the 3D printer finishes, have the lights do a ballyhoo. That's an idea I think you had last time that I loved. Or yeah, have the lights point at the phone when it rings. All of this speaks to like a broader need for automation in my home studio, office, workshop, all of the above. After I hopefully see this brighter, I tell you the other thought I was having about that today. But let's first just make sure that this works. So now, red, green, blue. Interesting. Still not particularly bright. You know what I'm going to do? I'm going to power cycle it because it does go to white when it first boots up. And I feel like this is significantly brighter than... Yeah, I think you can see it get dimmer when the DMX goes to 0. Oh, you know what it is? All right, lighting people. Can you guess why all of my channels might be, percentagely dimmer than I was expecting them to be? What control do we have in lighting control systems that makes everything dimmer? I know you're all going to shout it out, so yeah, I don't need to wait for it. It's this little board has almost no features, but it does have a Grandmaster, which is almost all the way down. So let's dial that up to 11. Yeah, there we go. That's more like it. That's brightness. I mean, it's blowing out the camera in a pretty serious way, right? Red, green, blue, green, cyan, amber, and magenta, and white. That's more the intensity we were looking for. All right, well, that's just groovy. Kill that for now. So now maybe we get this. I guess probably what I should do is get the wires prepped for the other one of these now and then install them both at the same time. Why is none of my DMX code? The number of times that I have been stymied by silly things like the Grandmaster being down, or frankly, for those of you who remember the days of the Demilight project where each of the boards had a physical toggle switch on it that you had to switch back and forth between operating mode and programming mode, right? Before we were using the serial interface to both program and receive DMX, and so they would fight with each other. And the number of times I was like, why is it not taking DMX? Because it was still in program mode and not in functional mode. Yeah, I'm always glad when it's a silly thing, right? Because it's always an easy thing to fix. Still frustrating though. So let's get the other star here focused or installed. And yeah, you get to see more of this cool sweater that I'm wearing, even as sweater weather is quickly leaving us behind, which I am so grateful about. I don't know about y'all, but like that first, at least this is, specific to Chicago, but there was a day when it had been snowing for weeks, and then all of a sudden there was a day that was like, and it was like 33 degrees, like not actually warm by objective standards, but just for where we were at in the year and in the world, it just felt like hope was in the air. Oh, Chris says this is fake spring. Yeah, we're in the traitor's spring that gives false hope. But I don't think it's so wrong to take a little bit of solace in a little bit of warmth. Although your point is well made, Chris. We are almost certainly not out of the woods yet, as it were. But the things are melting down, not melting down, things are melting incredibly fast. The snow is just vanishing, like noticeable amounts between, when we do the morning dog walk and the afternoon dog walk, which is just swell. All right, there's three bits of wire there for us to work with. Let's see, Landy says, had a whole universe... Oh no, had a whole universe park itself at 0 in the middle of a programming session on an emphasis. Oh no, it happened again a year later. Oof. Yeah, that's the kind of like, if it happens once, it's like, well, that sucks. The fact that it happened multiple times and that is awful. Ugh. We had, I'm sure I've told this story at some point, because I only have like 3 stories, but, you know, here you are. Back when I was at Looking Glass, we had an Expression 3 for a long time as our primary console. Sorry, I was reaching for Sharpies to color some wire. And it, like all Expression 3s, started. Lenny says there was a lot of yelling in the booth. Yes. What do you mean none of those things work? They just worked. Well, who unplugged what? Well, I didn't. So this Expression 3 that we had going, which was about as old as I was. This was back in 2014, I would say. It was going. It was occasionally having issues. We were programming a big old musical on it, and it was occasionally like hanging and freezing, and we'd have to reboot it. And as we got closer and closer to previews, the problem got worse and worse. Like it, you know, originally it froze once in the middle of pre-programming before tech. I'm like, well, that's scary. Maybe we should really start evaluating, you know, how soon we can get a new console in here. But one freeze in, it's fine. And then it happened again, and it happened during tech, and then it happened twice in the same day, and we were like, okay, we got to really accelerate this. This is when I was the assistant master electrician there, and it was also just before my boss at the time was having his first kid. So we ended up implementing a solution where, and so we had an Expression 3 running, right? And we just went ahead and ordered an Ion to replace it finally, which we've been talking about for a couple of years at that point. But tiny theater company, not a lot of budget, like, you know how this goes. But it's like we can't run a show with a light board that doesn't work. So we ordered an Ion, and while it was on its way, just to sort of get us through, we rented. No one had an Expression 3 in town to rent, but Design Lab, one of our local shops for those who remember them, had an Expression 2X, which is show file compatible. So we rented their 2X, and we ran on that for, I think, 3 days, and then the 2X, which was, I'm sure, older than the Expression 3, had started to have similar issues. Not identical issues, like it wasn't like the building was haunted by the ghost of, you know, floppy drive failure, but enough that it would also sort of freeze and hang and stop running. So for, I think, 3 days, including opening, until the Ion showed up and we got the show file ported over and checked, our solution was we'd run the show on Looking Glass's Expression 3, and we'd run the show on this rented 2X the same time, literally pressing both go buttons. We didn't want to slave them together in any way in case when one died, it did something awful to the other. So we had I'll get the full view. Tell this story. So we had the 2X on one hand, the 3 on the other, and whenever we took a GO, you'd hit both go buttons, and they were connected both with a net 1, right, an old ETC net 1 or ETC net connection to the dimmers. Go, right, and then the Looking Glass's Expression would die. Right, so you take the jack out of the wall, or we had 2 little jumpers, 2 little Cat 5 jumpers running up to a Cat 5 turnaround plugged into the cable that ran to the wall that ran to the dimmers, right? So this one would die. You'd move the cable from the house board to the rental board and keep going. And then you'd reach around and you'd reboot the house board and keep running the musical, right? And this one would boot up again, and you'd go to queue and you'd keep it running, right? And then this one would die. So you'd move the cable over and you'd keep the show going on this one and you'd reboot that one. Oh, and it was just, it's one of the moments that, like, and you've all had them, like, I'm tremendously proud that we were able to make it work, and I'm tremendously sad thinking of what we had to do to make things work. It you know, as a really janky system, it worked okay. The biggest thing was we had, I think, 4 IQs in the plot, the moving mirror fixtures, and they really do not like to lose DMX when they're powered up. If they do, you're really supposed to, or you should, power cycle them. They get very confused if they have their DMX stream interrupted while they're powered on. Huh. Sorry, just a little bit distracted here. So one thing I'm noticing is I was like, oh, I can daisy chain these two stars together. They have daisies for ground and data output, but not the power pin? And only 5 pads. That's not super helpful. I mean, I'm gonna daisy off this anyway with power. Like, it's gonna be fine. It's just a little bit of an odd design choice. Like, it would be a lot easier to daisy chain these if you had a separate power pin here, like that was just, you know, in parallel with. Choices. Well, that's all right. Let's get this other bit of wire soldered on. I guess let me do the easy ones first. So we'll do ground. Get the solder back. Ooh, you're still like looking real close there. Let's zoom that out just a little bit. Yeah. That rental shop is no longer with us in Chicago. Design Lab folded a few years ago. And then there were sort of 3, this is just a little bit of Chicago theater rental history. There were really 3 small shops, lighting rental shops that catered to the storefront, the small, the local, the high school end of the spectrum. Not that the other larger shops didn't as well, but Chicago has a local branch of VER, right? And if you wanted, 18 trucks of stuff for Lady Gaga, you'd go to VER. There's also TLC down in Burr Ridge and ILC out in Morton Grove or Arlington Heights, I guess, and other larger places. But there were basically 3 shops that catered to the smaller end of things. Chris, I would include ILC. Well, back in the day, ILC was Intelligent Lighting Creations was one of the smaller ones. They got a little. They think of themselves as quite a bit bigger now, and they are quite a bit bigger. They decided they wanted to move into a bigger market. Now it was Design Lab, Grand Stage, and Chicago Spotlight were sort of the three smaller ones that were around. Just move this into camera range. I'm just gonna sort of bodge solder this in here. Maybe I'll do it from the top so it doesn't get in the way of the VHB. But then Design Lab folded, and then Grand Stage and Chicago Spotlight merged a few years ago. So now, right now, I don't know. They are still extant, and we're actually ordering things from them from the museum not infrequently. But the options for renting relatively low cost, like if you want a bunch of the newest movers, you could go to TLC, you could go to ILC, you could go to Upstaging, you could go to, there's lots of options. But if you wanted like a couple dozen Lecos for your Gymatorium production for 2 weeks, PRG doesn't want to talk to you, right? They don't want to send you anything less than a truck, unless it's something really special. Wow, that's a bad solder job. Let's go from the back. Like I reached out to them about some things while I was at Looking Glass, for like 2 moving lights, and they were perfectly nice about it. But I definitely got the vibe of like, it's just it's not worth their time to rent 2 Mac 3500s to me. As a little tiny rental person, it was definitely worth it for them to rent, 2 Mac 3500s to me when I was, or I guess it was 4 when we were working with like Philip, who is also getting 300 movers for them for Broadway, right? They want to keep on somebody's good side. They're not fools, but somebody sort of out of the blue being like, hey, can I get 6 LED bars? I'm just not worth their time, and that's fair. I've seen the Apollo spot effects? No. Chris, I have not seen the spot effects. Tell me more. While I solder this thing. And if it's really cool, we'll go look it up after this. Power. Get the power pin in there. Gosh, I'm already regretting my choice of stranded wire for this connection, but sometimes you have to live with the choices that you've made. Power, data, let's get those. Yeah, all right. Let's do this one at a time. Let's power pin in, and then we'll go to the fancy, then we'll go over to the micro stage and get the truss warmers installed. Won't that be fancy? Honestly, I hadn't been thinking of it for a nameplate, except then I came to put that camera view into my stream controller. I was like, what do I call this view? Like, what is this camera? I was like, I don't know. It's the little micro stage. It's totally pretentious, but I kind of love it. Let's see, Thomas says their independent shop was acquired by Four Wall. Oh, nice. Still being a decent rental shop. Well, that's good. This was kind of, I went to Northwestern for undergrad back in the day, and Intelligent Lighting Creations was like a little local shop near there right when I started, but they decided they were going to get bigger, and so they moved out to the suburbs to a bigger warehouse, and at one point just got rid of all their conventional inventory, became an all LED shop, and just sort of stopped returning our calls. And that's that's fine. Like, I totally respect a business being like, we want to shoot for a different target market, one with more money. Like, that's totally legit. It was a little bit of a shame that they sort of like just cold shouldered everybody instead of being like, hey, why don't you go to any of these other local resources that you should know about? But in any case, Chris says tiny gobo projector that fits in the palm of your hand. Feels like a mod to a Demilight or a Demilight IQ. Ooh, that's fun. When you say gobo projector, Chris, like, does it have moving function to it, or it's like just a little tiny, like you put a tiny gobo in it, and it sends a gobo out? Because the thing I think of is the thing I think of a lot with this project is dark lights. Or Gantom, I guess they are. They started as dark lights and now they got fancy and they're Gantom. Also has a really tiny gobo projector that like a little LED emitter. All right, well that's story time with soldering. 12-volt LED, yeah, yeah. The Gantom has the Gantom names for their product lines are kind of goofy, I think, but Gantom also has a tiny gobo emitter style thing. Maybe we'll get to play with them. We have a lot of, this is trade secrets, we have a lot of Gantom fixtures coming in for one of the lighting overhauls at the museum coming up. Let's see. So I'm going to come over to my code, and just as a place to start, we'll make everything the same color on both of these stars. So let's upload that. So I just basically changed the number of pixels to 14. And then in this code that we wrote a couple weeks ago, basically we're going to call the set all color function with the values of DMX at addresses 1, 2, and 3. And those are addresses 1, 2, and 3 relative to the start address, which is fixed, I think, at address 1 for our purposes. And when we call the set all color function with 3 numbers, it just sets all of the pixels to that red, green, blue value, right? So I tell it we have 14 pixels to control, and whenever the DMX value changes, it just says, okay, well, all of the red, it corresponds to DMX value 1, all of the green corresponds to DMX value 2, all the blue is DMX value 3. That's all that's going on there. Let's come back and test it. Yes, the precision DMXable. That sounds right. Oh, the precision. Yeah, the Gantom precision. It's funny, we were just talking about Gantom fixtures at the museum the other day because of the way that they handle DMX is also not dissimilar from how I do, right? Like, especially the Gantom Go line. Power on. Yeah, there we go. All right, let's get this over to where we can... this doesn't bode entirely well. Red, green, blue. What I was saying doesn't bode entirely well is the first string got a little bit goofy there for a second. I was worried maybe we had a bad solder joint. But we seem to have red, green, blue, and master. And master. That's fun. The Gantom has sort of 2 different incompatible product lines for how they handle power and data, is my understanding. And the way that the Gantom Go line, there I am, hi. The way that the Gantom Go line handles it is literally with Y splitters in the DMX chain. All their DMX, I think, is over TRS, like 1/8" connectors, 3.5 millimeter tip ring sleeve connectors. And so like if you run a DMX line along on an 1/8 inch cable, then you have literally an 1/8 inch, like a headphone splitter, a TRS 1/8 inch jack, 1 to 2 or 1 to 4 or 1 to 8 splitter. And then you plug your local light into that and the DMX runs out along the line. And one of our consultants, and I don't blame him, made us, the reason we were talking about this is we were talking to our lighting vendor about, so if we were thinking that the DMX daisy chained through the fixtures, and that if you wanted to connect 2 of their cables together, you'd need literally an 1/8 inch barrel, a TRS female to female barrel. And so that the techs who run the exhibits day to day would need to be made aware, hey, if you take a light out to service it, be sure to put one of these barrels in, because otherwise you'll interrupt all of the rest of the DMX chain going down the line. And then we did just a little bit of digging on site. I was like, oh, no, they use Y splitters. And one of our lighting consultants was like, is that kosher for DMX? Really? Y splitters? And he's not wrong. Like the whole, like you always hear, and Thomas, I hope you're hearing in college, and Dave, I think hope you've been hearing for 30 years, right? Or however long you've been in the field, not to make assumptions. That like you don't do Y splitters, right? The whole point is that you have opto isolators and each line is one linear line. You don't use Y splitters. The truth is, and I'm just going to get up on my soapbox a little tiny bit, is that small deviations from that form factor are fine, because when you think about what's happening, say, inside of a moving light, right? If you have your DMX coming in, and then it plugs into a VL3500, and you plug in DMX to the output on that 3500, and it goes on down your truss, right? Well, inside of that light, between those 2 connectors, there are wires, 6, 12, 18, 24 inches of wire going to a circuit board and doing something. And that is part of the same DMX chain. Essentially, it's like you have a little Y splitter at that point in the cable with 6, 12, 18, 24 inches of wire going down to your circuit board. The RS485 spec, and for those who've watched either the, ages ago, last fall, we did like a class on RS485 and DMX video or stream on this thing. The maximum amount of deviation when you're running RS485, which DMX is, at a relatively slow bit rate, right, 256 kilobits per second, you can deviate by that from a straight linear topology by up to something like 17 feet. It's fine, right? RS485 is meant to go, 1,000 feet, a couple thousand feet down a factory line and keep all of your machines in sync. And so if you need 6 feet of wire inside your robot to get your signal where it needs to go inside the thing, that's fine. So our consultant was right to be snarky about Y splitters, and I am too, but it's the same reason why I'm like, I'm gonna make a little tiny board that like just splits some DMX and power all over the place, and it's gonna be fine. I'm going 500 millimeters down the way. That'll be, if I were to put a DMX signal that split here and went 500 millimeters down each of these truss, we'd be fine. I think. Or maybe we wouldn't. And then I would learn something, and that would also be kind of cool. I would love to be, I'm doing this all with the assumption that I'm right, and evidence has shown that I seem to be right, but if I turn out to be wrong, we'll learn something. All right, let us get this installed in some truss, and I'm realizing that as good as this view is, well, this might be kind of fun. It's gonna be a little bit finicky for me to get this into the truss. This just goes back to Chris's point. It's gonna be kind of finicky to get this into the truss with the truss already hanging here, especially because of a choice I made that turned out to bite me when I was designing this mounting flange right here. It means that there's not a lot of thread on this 1-inch machine screw to get through the mounting hardware and the plate to get a wing nut onto. So getting this on was kind of a pain. And getting it back on would also be a pain. So maybe to where we started this evening, maybe it's time for a little bit of a 3D print redesign. Let's go take a quick look. Let's go over to the computer, and we will bring up, where's Fusion? There we are. Let's modify this to be better. Transformer plate. No screws. Yeah, Chris, I recessed the bolt or the head of the machine screw in the previous version, in that red version that didn't work so well. And I just got lazy with this. I was like, I don't want to make a third version of this hook. It's fine. It was not fine. So let's see here. What order did I build this in? Let me roll back my timeline here in Fusion. Let's see. Looks like the last thing I built was this LED star, which is unfortunate. Because so this is the shape that I mean to replace. You can see, you know, that's the end cap of the truss. This is our mounting plate here. Ooh, Landry says, we discovered the university theater I was at had the building's DMX wired as a massive Y. DMX 100 feet to a J-box with wire nuts and splitters to 100 to other locations. Works surprisingly fine. Yeah, RS-45 is relatively tolerant. It's relatively low speed, and right, and it's the kind of thing, right, where it's like it's fine until it's not, right? It works perfectly good, and then you just have one too many loads on the line or one slightly sketchy terminator, and then it all falls apart. But for a lot of things, you know, it's remarkably robust. So I think what I'm going to do is still assume we're going to install this at the end of the truss. We're just not going to involve any of this hardware. And partly that's because I'm lazy and I don't want to re-implement this LED design. And partly because I think as far as like a position and a thickness, being as close to the end of the truss as possible is kind of nice. And this I sort of picked an arbitrary width of, I don't know, a couple millimeters there, whatever that is, but that's a nice amount of stiffness while still printing pretty quickly. So I think let's come up with, and I deleted the rest of my truss segments here, just to try and save some polygons. This goes back to like the other thing we're talking about tonight is computers dying when they're running too many polygons at them. But I think we can come up with a design that fits maybe within two of these truss members and sort of sits up here. And if that doesn't make sense, then it will shortly. How do we want to, maybe, since I'm re-implementing this design from scratch, what I think I'll just do is just go back into this initial sketch, which was, so this was my, that was a sketch for the LED star, so it must be this sketch. Yeah, so this is the mounting plate for the LEDs themselves. And we'll just modify this and come up with a sort of new outline for what our truss warmer mounting plate might look like. I'm not sure the Techno even knew what terminators were. Yeah. Man, we ran into a thing, speaking of tricky terminators, we ran into the thing, so when I was working at Chicago Shakes, we ran into a thing. So I was there when we were building the new theater, the yard, and it was a reconfigurable theater. But the point of it is, oh Jesus, this is going to be a project nightmare. Let's not project. Sorry, trying to figure out how to. I think we've been here before, Thomas. I feel like you and I and Chris have discussed like how to make circles out of STL meshes in this thing, but this will work fine enough for my purposes. Just going to project a point. You know, part of having a reconfigurable theater is having reconfigurable house lights, right? And so what we had for house lights was 35 color source pars, you know, standard ETC, RGB, lime, color source pars, and I think 18 color source spots, which were aisle lights, and they were, I'm sorry, drafting and talking at the same time. They were run from, so the aisle lights, of course, like any good theatrical aisle light, have to be run on emergency power in case the power goes out, people still need to be able to get out of the building, right? And so they were run on their own circuit and their own EDBK system, right? The Emergency Data Backup Kit system, which ETC also makes, where, you know, I should hold off on that mirror operation until I was mirroring this circle across to the other side of this plate, but I should really just design one whole side of this thing, and then come back and design the other side. I think what this is going to be, so I was going to, my first thought, so we'll come back to the story about the EBDK and stuff in a second. My first thought was something sort of T-shaped, right, which we'd have maybe a press fit here around this truss member and around this member, it would sort of T across and go up. But what occurs to me is there's going to be a big wing nut here that's going to be in the way. So really we kind of need to go either between these two members, although this diagonal is going to be in the way. It could be kind of a star-shaped thing that sort of slides into place. That might be kind of interesting. That might be kind of interesting. So let's see, how would that work? We would do, let's do a line between these two, and we will set it to 45-degree angle. And we will make another line that is, I guess, let's, I was going to say we'll do it in parallel, but I think the safer bet is actually to do a second line that is also tangent and touching the center circle. There, it does not want to be a construction line. Let's make sure, so it's coincident, it is tangent to that circle, and it is parallel to this other line. And let's do a little offset here of maybe 0.05, just to give ourselves a little bit of wiggle room. Something like that. Chris says, oh, wondered if it's better to mirror sketch parts or mirror the body and only sketch half. You know, I personally go back and forth on that all the time. And I don't think there's a one right answer. I think it's situational on what it is that you're drafting and whether you're going to want to be able to maybe interact with each half of that sketch on its own later. Let's see. I guess we should do this as an offset as well instead of as its own circle. Let's offset that maybe 2 millimeters. And then we'll bring a line across here, and we'll make that perpendicular to these other lines. If this is all just a bunch of rambling, and it kind of feels like it is, I'll be totally honest, probably because I'm drafting and talking at the same time, in just a moment, it should hopefully all make sense. Oops, failed to resolve. Let's make this parallel then. Let's see, what is this? Oh, this is running, this line became parallel to something I didn't intend for it to be parallel to. Let's see. There we go. Now this wants to be parallel to that. There we go. And then I don't think it'll let me fillet this natively, no. So maybe we'll do that as a second operation. Pet peeve, you can't offset an offset line. Yeah, Chris, that is a, I was gonna say a known feature. Feature is probably the wrong word, huh? But yes, you always have to offset from whatever your base was again. So like here's an example, let's just like to call it out. So this arm that's going to stretch down from our central mounting plate to this member here is itself symmetrical, right? Like, oops, I don't want to joint. I could have modeled just half of this arm in the sketch and then maybe mirrored its body across. But to me, it makes, like, the way that my brain is going to absorb it best is, what are you aligning yourself to? I have all these, oh, you know what's happening? I have all these projected little line segments that came in with projecting this body, this mesh, and it's like snapping to be perpendicular to some of them just because it can, which is not really what I want it to do. So rather, I could have modeled just like half of this body and then mirrored it across a center line. He said waving at his screen like anyone else could see it. But I'm going to model this whole arm and then mirror that. Like that's where my brain goes as far as the logistics of this device. I like to, and this is just a matter of personal taste, I like to model my fillets into my sketches. Like you can see, I could have extruded this and then put a fillet in the body, but I like to put the fillet inside the sketch itself. But that's just me. at least for a simple 2D fillet shape like this, right? If it's going to be something between multiple bodies in multiple positions like that, I will certainly do, I will extrude or revolve or create the 3D bodies and then put the fillets on them. But for something like this where I'm sort of defining the 2D outline of a shape, I do like to put the fillets into the sketch itself. And the easiest way for a shape like this, so right, if you have two linear shapes, you can just use the fillet tool. If you have something like this where you have a rounded shape, like a circle and a line coming together where it won't let you use the fillet tool, you can do a circle tangent to both shapes. And that will create the little, the little space in here for your fillet. I'm going to get rid of a few of these old lines that'll just get in our way. And then you have the choice aesthetically, do you want to trim those parts of your fillet back? Or leave the circles there just as like a slightly cleaner representation of what that dimension was. For our purposes here tonight, I'm going to trim them, but I think that'll be fine. Oh yeah, see, Chris is off to the side here, off to my side here, saying I could create those fillets later. Chris is a post-body creation fillet critics like to mess with them in the timeline instead of editing sketches. Totally fair. Yeah, Whoa, why isn't your lowest fillet fully constrained? Oh, I think because of how I deleted it, Chris. I think it is, it lost its dimensioning. Oh no, that's interesting. Because it should be a mirror. Maybe it lost its mirror relationship. Yeah, it looks like it lost that mirror relationship when I deleted part of it. Huh, interesting. Well, now it's back. So now, let's adjust our extrude here. We'll get rid of this bottom tab. And actually, you know what, let's do... yeah, no, here. We'll just do this center section as its own piece. We'll get rid of this top tab as well. New body, so this should be just our center section here that actually holds our LED. And then we'll do a second extrude from that same sketch, which we'll bring back up to be visible again. And we'll extrude, and I could do this a couple different ways, right? We could extrude this as its own body and then mirror that body, or we could extrude it and join it and then mirror that feature. I like to personally mirror bodies and then join them. The result is going to be the same, but for some reason that feels more natural to me. The interacting with features always feels just like a little bit. I didn't mean to select all of that. Get rid of this. So this is going to be a press fit into. I should probably fillet those edges. Come to think of it. Interacting with what it thinks of as features always makes me just a little bit nervous. I don't know why. It just feels like feature is an undefined term. But maybe that's just me. Ooh, here's the other thing is, am I going to be able to mirror this with sufficient precision for it to not hose me? And I think I can, but instead of mirroring across geometry from this mesh, which could be slightly offset from itself, I'm going to define all of my features relative to features that are already in this sketch. All right, so I'm going to create a perpendicular plane down the center there, and then I'm going to use my body's mirror tool to mirror that across this center line. That creates those two new bodies. And then I'm going to hide that plane, create another plane at angle across the other center line of my sketch, and then use my mirror tool again on those two bodies to mirror them up. And then finally, I will use a combine tool. Oh, except for some reason these are shorter than the other parts, but that's okay. We can figure out what that actual dimension is. In fact, what I should do is just at that point in the timeline, we'll roll our timeline back. We'll create an offset plane just flush with that face, and then when we do this, extrude this first arm, we'll just take it to that plane. Plane, new body, great. And then we'll roll our timeline back to the end, and we'll do a combine operation, combine with the center, and we'll join the four arms to it. And now there is our new shape. not extruded surface. So I think, so we've talked about this before, Chris, and let's see if I'm wrong. And I often am. So in this situation, right, so this was that, going back to that point where I'm going to extrude my first arm here in a second. If I just do extrude, here, let's go into my extrude here that we're doing. Extrude to object. I guess it does select that plane. I'm just so used to often like this plane, like it won't necessarily let you, I often get tool body creation failed errors, I feel like, when I'm extruding even toward a planar surface. So I just default to always creating a 0 offset plane. I mean, clearly that is unnecessary, right? This is actually about the first time we've run across this, is that's just an oddity of how I'm working. I just feel like I get that error more than I want to. You know what I'm also seeing here, although maybe it's not a huge issue. Look how my plate is interacting. These are the cutoff bits of the diagonal members. But I think that will be okay, because that means this plate will just sit a little bit further, a little bit further from the actual end cap of the truss. And I'm seeing that there's some stuff on here that I do want to fillet. So let's roll back to just after that first extrude, and we'll do those changes on our first body here. Remember how I said I like to define my fillets in my in my sketch? Well, here I am filleting my body after the fact. Let's see, I want to do some little fillets on these interfaces here, just so they maybe slides onto those posts a little bit easier. Ooh, that's a little much, huh? Maybe 0.5. These arms are going to be really small. All right, and then let's roll our timeline back to the end. So something like that, in theory. I guess in principle it could just be 2 of the diagonals, right? It doesn't necessarily need to be all 4, although that could be a little bit unstable. It's kind of an interesting design. Anyone see any glaring issues with this design? I mean, we've noticed that it's going to intersect the diagonals here, so we'll just have to sit a little bit further from the end plate. I guess it could interact with a wing nut here, which would be less than ideal. But if that's the case, it would also interact with the Neopixels themselves, which are a little bit smaller than this plate for sure. That's, there's a little bit of extra mounting room there, but there's not a ton of clearance. So I don't know that like holding that out to specifically clear a wing nut is going to be super helpful. And then our LEDs get mounted. Oh yeah, here, I can actually bring all of that back. Let's roll our timeline to the end. There we go. This is seeming a little bit big. Maybe we'll shrink just the overall size of this center plate here a little bit, just because we can. Not LED. Let's go back into our mount. We'll go back into that very first sketch. And what's our radius here? 28. Let's make that 24. Or diameter, I guess, not radius. Hopefully that doesn't send our sketch into the netherworld. Failed to solve. Oh. I have too much geometry. It's not going to let me do that anymore. Well, that's all right. This will be good enough for a test. Oh, you can't see that. Well, there it is. It wasn't letting me do the thing I wanted to anyway. Totally different idea, Chris. What about clipping it to the inside of the truss end, the rectangular shape? Ooh, that's interesting. Let's, probably easier to explore that on the table here. So we get inside that shape. We could also look at it. Well, you'll be looking through the rest of the truss. When I said it was going to be easier, yeah, I was wrong. Let's just look at it on the screen here. And look at our mesh body. I should probably turn off my wires, which are what? Those. Yeah, so this is the shape that we're looking at here. So we start to have challenges with the diagonal members again, although we could go through this hole. That might be kind of interesting, like having it sort of mount inside of this, I guess it's an octagon, this chamfered rectangle here. That's kind of interesting. or even just like spanning between this side and this side. It's kind of interesting. These two are sloped to provide a little extra reinforcement, I think. I don't hate that, Chris. Sort of mounted like either like squeeze in or clip in into this side or into this octagon, or maybe both. Well, I'll tell you what, since we've got this one prepped, let me get this first one printing, and then we'll go from there. So let's bring this over into Prusa Slicer. Let's see. So I'm gonna take my body, and as we chatted about last time, wow, there's two little tiny bodies hanging out other places. Look at that, he's just hanging out there. Some part of the extrude that I didn't catch, but I'm not gonna bother cleaning up now. Can always do that later. Let's call this warmer plate X. And I think we chatted about this last time we were on stream. We could use Fusion's feature to bring this file directly into the slicer. I like to save every STL and every G-code file that I have ever made. Not for any particular reason. Well, not any particular reason. I sometimes find it useful to have that information on hand. Especially old G-code files when I'm like, oh, I would love to match this thing exactly, but I can see it, like, why did I print it like this? What settings did I use? That kind of thing. And having the G-code means that that's portable between slicers as opposed to something like an M3F, MF3, whatever the 3D manufacturing, like the slicer settings file, because you can recreate all the settings from the exported G-code comments. Yeah, 9 minutes, Chris, not too bad. Well, let me get that going. I'll be just over here at the printer. We'll see. I know my mic cord will stretch. I don't know if my headphone cord will, so this may get a little bit cattywampus. Not that my, headphones are strictly necessary for this endeavor, but I'm just listening to the same cool jams that y'all are, and that, to be candid, that's been the background of these streams for the almost a year we've been doing them now, and it just feels like a little bit odd to be streaming without some of those chill vibes. So I like to keep them going. All right, so here's our flash drive. We'll go back into the as printed. So you can see, like, this is my folder of stuff as printed. So this is basically every G-code file I've generated back to, I mean, this is just back to when I got this computer, although I do also have all of my archived ones in here somewhere. Yeah, all of this stuff I imported on 1/6/2019. So basically every G-code file I have ever used, at home at least. Oops, don't open that. No, don't open that. No. Just want to put that on the flash drive. Get rid of the other former G-code file. Eject. All right, let me pop that into the printer. Without headphones, I can't hear you. I really wish there was a way, and there probably is, come to think of it, like, I'm just looking at, YouTube chat over on the side to see what all of you fine folks are saying. And here's a moment. I gotta take my headphones off to reach over to the isopropyl, because I'm gonna clean the bed again before we get this thing rolling. I wonder if, there we go. Wow, it's so funny. I'm so much louder without my headphones on. I wish there was a way for, like, the YouTube chat to make a little, like, bing bong in my ears when a chat message pops up. Just because occasionally we go a while without chatting, or I'm working on something and I don't see what somebody smarter than me is saying off to the side. That might be handy. I'm sure there's a way to do that. I'm not, as I've said before, I'm not a streamer. I'm not really intending to be a streamer. I'm a guy who makes things, and I'm really having fun sharing that with people along the way. And frankly, selfishly, I benefit from, having everyone's smart ideas here in the evenings on Sundays. So as always, thank you. But it's not like I'm trying to, become a 1 million subscriber thing. I just have fun sharing this with people. All right, well, yeah, 9 minutes, so that's going to take an age. let's see. I wonder if we can come up with a viable Chris suggestion version in 9 minutes. Probably not, but that's okay. Let's call it truss former plate rectangle. We'll just save a new design, and we'll do the same thing. We'll just go back into that sketch, and we'll figure out how to... Maybe we just start something new. Yeah, let's just go back into our base here. We'll get rid of our mount. We'll start a new component called the snap mount. 9 minutes. So I think, Chris, I might be wrong. I think the time estimates do somewhat account for like the preheat and measurement time because, for example, earlier when I was printing the first iteration of these truss plates, like one was going to take 7 minutes, but 3 took 21. Where it was calculated to take, one was 7, 3 was 19. Like there's 2 minutes of saved time there by doing 3 of them that I can't quite account for unless it's factoring in like the 2 minutes that it takes to preheat the first time or whatever. But I haven't really thought too deeply about that. So yeah, what could we do here? So here's this LED size. So we really don't need anything really any bigger than... I mean, frankly, there's probably a way to just have this sort of stick into... Instead, the LED itself just stick into the end of this truss. Really, all it needs is like some kind of, horizontal support across here. Maybe we do this just like the simplest, easiest way. I think, I know it's, we'll do a sketch on, let's say, this face. We'll project the mesh body in, and we'll just draw, let's bring... We'll bring that side into our sketch. We'll bring this side into our sketch. And there's our body that we're working with. And let's just bring a rectangle across. Let's put it on center line just for gits and shiggles. And we'll put a rectangle, say... here that goes all the way across, and we'll leave ourselves just do we want to leave? I guess we should leave just a tiny bit of clearance, but since we want this to be a pretty tight snap fit, maybe that's unnecessary. Maybe, I think let's do like 0.05 millimeters on either side. We'll do 0.05. Basically no additional clearance, but just a little bit. To allow for plastic creep. Oop, not 5 millimeters, 0.05 millimeters, so we plenty. And we will make this whole thing, I guess let's mirror this line and those 2 little offset lines, 1, 2, and 3. We'll mirror those across our center line here, and we'll make the whole thing maybe 10 millimeters tall. Sure. 10 millimeters tall. We'll want this to be collinear with our center line. There we go. So that's nice and constrained. We'll extrude this out. Let's say 2 millimeters. And we'll bring that sketch back. And we will extrude this backside out 2 millimeters. Oops, how about minus 2 millimeters? And join it. So we really just have like a snap-in plate that I guess it could still slide up and down in this configuration. So we could make it a little bit thicker so it couldn't slide anywhere. Is this kind of along with what you were imagining, Chris? This is what popped into my mind when you said snapped into this space. But maybe this is not quite what you were thinking. Maybe we will... just give ourselves a little bit of like a reinforcement in the center here. All right, and then we will pretty close, says Chris. Yeah, I'll take pretty close, something like that. I'll mirror that, and then we will mirror 1, 2, 3, and 4 lines. We'll mirror those across the center as well. All right, and then our first extrude includes those regions, and our second extrude includes those regions. So we have a little cross that kind of snaps in there, fills some space, just enough to stick an LED onto, something like that. All right, great. And let's see how much time we have left. We're only at 58%. We're only at 58% on the other print. We're gonna make it. Very good. Here we haven't even enough time to do some fillets. If I was naming the streams after the fact instead of like when I scheduled them, this one would be called body fillets, a stream. Let's see, do we want to, I probably want to fillet these corners so this thing squeezes in just a little bit better, huh? We'll do like 1, 2, 3, oops. 1, oh, I guess that's 2 edges put together, 2, 3, and 4. Just a little bit of a fillet there. There we go. And I guess we would want to do the same with 1, 2, so that those squeeze in a little better there. Maybe that's a little too extreme. We'll do a 1mm fillet. Yeah, it seems fine. All right, that is okay. Now that's our second option. Let's get that sliced, and then we'll get that printing as soon as the first one finishes. That was a good point. Have we updated the schedule at the bottom of the stream at all? No, to be perfectly honest, I think we did that. I did that first for the night that we were walking through the build of version 0.94. These days, it's less of a schedule and more just of a here are some things we're going to talk about tonight. But no, I actually have in this iteration removed the advance through the schedule button from my controls. It's just here's some stuff we're doing in some order. When we come back to maybe a more structure, when we're building 0.96 or doing a show, at that point, I probably will bring back the advancing through the schedule. But no, you're exactly right. I have not advanced it at all, but that is for once on purpose. But I guess that means it's when we come back to actually using that, it's on me to be like, hey, Thomas, Chris, Landy, broke both. Help me. Help me, stream audience. You're my only hope. Well, this one also is going to take 9 minutes. Well, that's easy. Chris is ordering some differently sized nozzles. Yeah. Let's see. We are at 90% done on 91% done. Sorry, on the first print there, which you can kind of see printing away, doing its thing. So I guess one little note on that, I was about to say I'm so happy with this printer, and I still am. I think I mentioned last week how I was having some issues with the printer. I had several failed prints. I actually had one more failed print this week, which I think was my fault for a poorly executed model. The issues I was having with printing and clumping, I think what happened, I don't know what caused the first of those failures. I think the second one, which was the more catastrophic one, was caused by me not sufficiently cleaning the nozzle and the surrounding area after the first failure. I think what happened, just looking at its aftermath, was that at some point, for some reason, the filament started to, after the first failure where some filament had accumulated around the nozzle, it was fairly sticky. I cleaned that off okay. Sometime during the second failure, what I think triggered it was some filament started to again get stuck to the nozzle because there was some accumulated detritus, stickiness, bits of filament, whatever. I don't know what the situation was that caused that to happen. Maybe there was some bridging. There was a travel that had a bit of ooze, and maybe something caught on that. I don't know, but I suspect that there was something on the nozzle and the extruder head itself that was making things more likely to get stuck to it. So after the second failure, what was really bugging me last week, I deep cleaned it with isopropyl and water and isopropyl, heated it up, tested it out, saw what it, got it really glistening clean. And so far, other than this one failure that I had yesterday, which again, I think was caused by a model which was sort of very tall and willowy, which I cannot talk about because it's part of a present for a friend. I think what happened in that one is as it got very tall, some parts of it started to wiggle a little bit as the bed moved around. And that caused a part of it to snap off and fracture. Although the print did finish, it just had some dangly ood-ness hanging down from the top of the print, but that's fine. How did I clean that part of the nozzle? So this is just based on impulse. I actually did zero research. I first did a cold, just like with the nozzle cold, feel around to see, like, is there any roughness, is there any obvious accumulated filament? If there was some, just sort of identify the problem. Then heat the nozzle up, and with a thick cloth and 90% isopropyl, just go around gently cleaning any oozing. If there's filament accumulated on the outside, I figure, right, you should be able to sort of just gently brush it off with a wet or damp cloth. And thankfully, I did not observe any filament deeper into the recesses like the extruder or the hotter or anything like that. That would probably require a more mechanical solution. I just sort of went in with a wet steam cloth at a hot nozzle. Not a terribly exciting answer, but that's basically what it was. But our print is done. So let's get that guy out. Ta-da! And before we check it out, let's get our second print printing. Preheat PLA. Let me grab my isopropyl again. So because I had these two failures, I have been now, of course, super paranoid about additional failures. And this is something I had always done for our work printer and had been kind of lazy about with the home printer, because I was like, it's a great, infallible printer. But much like, the Titanic, once you call something infallible, it is doomed to failure. So now I'm religiously cleaning the print bed with IPA between every print. Oh. Hello, Jess speaking. Oh, it's my wife. Hello, wife. I'm feeling... No, I'm feeling pretty good. I still have most of my beer, or maybe half, and we're 3D printing some things live on stream tonight, which is pretty exciting. Fair enough. Thank you, hon. Bye. Love you too. I think I've mentioned before how I have just the best wife, but it's absolutely true. She just called to check in, say hi, see if I had needed another beer, how I was feeling. She's so great. She's so supportive. Yeah, I'm a lucky guy. I see all the hellos in chat. I should have let her know. I will give her all your biggest hellos and welcomes, and about welcomes. She's in our apartment where she's been for the past year. All of your hellos immediately following the stream. I'm sure she will appreciate that. Let's see here. What did I call this? Truss warmer plate snap. All right. Yes. Well, good. Well, I'm glad the bat phone got some good use tonight. Always nice to give it a little bit of exercise. Make sure the ringer still functions. I've tangled myself horribly again, but that's all right. Don't have to go very far. All right. Let's get the flash drive plug back in, and there we go, and print. 9 minutes and 29 seconds, it thinks. Need some cable management. You know, really the most of the problem is, Chris, when I take my headphones off and then pick them up tangled around themselves, that is causing, I think, 60% of my problems at least. So I need a better cable management in me. I need me be better at cable management. Brooke asked a good question. Are you using any version control for your projects? I have a GitLab server. So not on the hardware side. Beyond like saving multiple versions of things and sort of the versioning of the Demilight. No, I'm not. To be honest, I have not tried for myself. I've not heard great things about like versioning and like Fusion files. I use Git and GitHub for the project code and the JDMX library, so that's all Git tracked. But no, not for anything locally. If anyone, especially if you if you have suggestions for versioning, version control that would be useful with, especially with Fusion files. I know a lot of people do version control on their like EagleCAD files, right, in their PCB software, on their PCB files, and I have not experimented with that. But maybe that would be worthwhile. You know what, let me get the contrasting piece of truss here so we can see a little better what's going on. Might be a little too snug. Maybe should have toleranced it. Oh, or I could put it in better. Also possible, you know what I should do? I think this one was, that black truss was printed on my old printer. This was printed on the Prusa, so it's going to be, if anything, more dimensionally accurate. I can zoom out just a little bit so there's not so much chaos. Oh, Thomas got his soldering completed inside of a tight squeeze. Good, excellent. Let's see, how is this? Ooh, oh, hey, that felt pretty good. So yeah, a little bit of a tight squeeze, but that's good, right? Because it's just a friction fit. So there's our new plate mounted inside. This is we'll call this our X plate mounted inside of our new truss. Well, that looks pretty classy, huh? So our options are, we'll have what we call our I plate, right, which was mounting to the bolts on the end of the truss. We'll call this our X plate, which is sort of for obvious reasons. And then in a moment, in 7 minutes or so, we'll have our snap plate, which will in theory be a press fit into the two sides and the recess here. Well, that's pretty cool. So, just while that other one is printing, I'm just now seeing this. Like, I'm not having any immediate thoughts, but like the impulse I'm having is: are there other uses for this kind of plate architecture? Right? Like the place my mind goes, except for these, cross diagonals here, is like if you had to run, an operating line for a fly system down the center line of your truss, say, you could use this to like guide your blocks. I don't know. There's just maybe it's just like, I don't know if anyone else has this, but like when you see something that's like, oh, that looks clean, like that's a nice solution, and the symmetry of it is appealing. It's like, what else could I use that for? So I guess just to do the demo here. You know what? Here's what I'm going to propose. Because as I'm looking at it and thinking about it more, I think having the truss warmers installed in this setup is going to be really nifty. But I also think that the process of you watching me on this grainy camera install them is going to be less exciting. I mean, it might be doable. But here's what I think. I think for testing purposes, this will be a good place for us to to do some demos. Why don't we'll take the X plate and the snap plate, and we'll install them at both ends of this piece of truss on the workbench where we can actually see things. And we'll turn the lights down, and we'll sort of evaluate them here locally, maybe one by one. Maybe we'll set up the DMX so that like left is addresses 1, 2, 3, right is addresses 4, 5, 6, and we can play with some different hardware options there. And then the actual process of like installing things in the physical truss over here in, you know, no man's land can be a side project like that. This feels like less exciting to do during a stream and more fun to look at when it's completed. You know what I mean? Yeah, exactly, Chris. Yeah. So tune in next time to see the. Yeah, those of you who've been here before, I don't think I can fairly say tune in next time to see the completed results, because I don't know how often that happens, but it's not a whole lot. To see what, but I will say one of the fun things about having, you know, the micro stage set up is it's like, because it can be here all the time, it's not temporary, and it's within reach of my workbench. I think you can still see, you know, over my shoulder there, like the first batten that we set up, right, with the 0.9.2 version with those 4-pin connectors on it, right? That batten was fun, and it looks great in the uplight, right? But it's so far away that I wasn't really, you know, I had to get up and work on it, and bring it back to the bench, and take the light apart, and do the thing, and go hang it back up again, right? This is so nice and close that it's much like when I was, you know, arranging the, you can see here, you know, I think I've showed this on the camera before, this whole tool setup of the most frequently used tools is also new. And when I set that up, I was like, oh, I'm using these tools a lot more. I'm much more motivated to come and just sit down and work on something because it's easier to get to stuff. I'm hoping, but not promising, that this setup will be the same. It's like, oh, the Kabuki rigs are right here. I should just play with them for a little while. That's the hope. But let's see how we're doing. 58% on the snap plate. So I guess we could get some of this programming done and some of the setup on the X plate here. So let's see. Let's make we'll say the X plate is going to be the first set of addresses. So let's get some more VHB tape down. I'll just stick these Neopixels in place. Let's see. Let me think about how I want to do cable management. It's not going to be here very long. I don't have to think too hard about cable management, but it'd be nice if it wants to be sitting like this, or maybe let's, for testing purposes, let's view it like this. He said, looking at the camera, because then we'll see the reflection on all of these side members. I think that'll be easier to see than just looking at it from the top there. So if we're looking at it like that, then I think I want my wiring to, yeah, we're gonna feed this through. And of course the wires are sized for the micro stage. It's funny, the more you start to say a term that you just made up, like the more plausible it sounds. Or maybe just for me. Maybe it sounds increasingly dumb for y'all, but like, that's kind of how Demilight started. As I came up with it one day, I was like, is that highfalutin? Is that dumb? Is that weird? And now I've just said it so much, like, oh yeah, well that's just what it's called. We'll stick that Neopixel star in there. And as that sets for a second, let's go over to our code. And we'll need to adjust it a little bit so that our DMX addresses behave as we want them to. So first off, I'm going to take out this pan and tilt. You know what? Let's say this is a new bit of code since we're monkeying around with it. We'll call this our Neopixel DMX. I know you can't see this. Neopixel truss warmer. All right, we'll take out the servo code. We don't need that. And let's see here. Let us write a new function. So this first function we have is called set all color, which sets the color of everything. Let's just duplicate that and make a new function called set all range, which takes a red, a green, a blue, a start pixel, and a last pixel. And then rather than going through all the pixels, it just goes to for int I equals start. Oh, I can't use the last keyboard. I'll call it the final. No, can't call it final. Highest. We'll call it the highest pixel number. I is less than or equal to, and we don't want to go past the end of our highest pixels. So we'll say the minimum of num pixels and highest I++ set pixel color. Ooh, yeah, Thomas. So Thomas is running his pancake servos at 36 volts, and they just have. I mean, compared to certainly the little like 5-volt crappy hobby servos that I'm using, I'm jealous of the torque that you have available to you in that form factor. So let's see here. We will do, so rather than doing set all color to value 1, 2, and 3, I will do set all range. Is that what we called it? Yeah, set all range from 1, 2, and 3 from pixels 0 to 6. And then we will do the same thing with DMX addresses 4, 5, and 6. 4, 5, and 6, and those will control pixels 7 through 13, because I'm pretty sure there is 0 indexed. In fact, we can confirm, yeah, so this loop was going from 0 to 13 before, so that's what our loop is. Set brightness. All right, so let's just make sure that compiles. Thomas says, does the Demilight firmware do any acceleration? No. No, it literally just immediately sets the, new servo output position to this, to, the new position, and lets the servos just get there with their own internal hardware. No, nothing quite that fancy by far. All right, we'll plug in our programmer here. We will upload. All right, that's uploaded. Unplug that. We'll bring our, I almost said our console. We'll bring our DMX controller back in. Let's see, we'll take the other Phoenix connector out. And we will plug our DMX in. Oh, and we'll make sure our power connectors are powered. All right, so here's our 2 stars here. So I should have control of just one of the truss warmers. Oops, no. Perhaps I have goofed my code. Oh, or I haven't turned my control board on. There we go. So I have red, green, blue, red, green, blue. Hey, first time. That's exciting. And, oh, and it looks like our other plate is done just in time. All right, I'm gonna just leave the control board on so I don't forget to turn it on again. Let's grab our other mount. Ta-da! Alrighty, so let's get that a little bigger. I'll zoom out a little bit so we can see all that's going on. All the chaos that's accumulated around this work area. All right, so there's the control board. Let's see here. Maybe we'll zoom back in and see how this plate fits. Made a little bit harder by the fact that there's now some wiring attached to the other end. Oh, I goofed. Oh, no, I didn't. Oh, I didn't goof. It's just going to be a tight fit. Ooh, yeah. So side to side, the tolerance is like just right. I can feel it wanting to snap. Up to this little cross member here. Ooh, oh, wow, that's a tight snap fit. That actually feels really good. And now that snaps down right inside there. That's also cool. Oh, that feels so good. So we have our snap plate there, our X plate there. We've sort of, the I plate, I'm going to keep the design around for maybe for future things that really do want to be bolted on, but that's going to go by the wayside for now. Let's get some additional VHB in and get the other side of our truss warmer in. Yeah, and you're right, Chris, because it's sort of recessed into that snap, it's not going to interfere with the wing nuts that would be sitting inside this truss here, which is really cool. So, you know, just thinking out loud, like pros and cons of the various designs, this one is sort of out of the way of the wing nuts when mounted at the end of the truss. The X plate, you could mount at different plates along the middle of the truss, right? So if you wanted a truss end truss warmer, you know, at the end of one of these members, maybe it's this. If you need to mount something sort of midway along a member of truss, maybe you use an X plate. Now it's kind of cool that we have both of those options. Delightful. All right, well, let me get this in view here, and maybe we'll adjust some lighting. Here, I'll tell you what, I'm going to put my desktop camera here in manual mode so we can play with exposure a little bit more directly. Let's get that sussed there. We'll get here. I'll get the console in view so we can all just enjoy the process of mixing these colors together. And so in theory, oh, my power wire has slipped off of my control board here. There we go. Red, green, blue, red, green, blue. Ooh. Ah. Ooh. I don't know how hard it... here, you know what? Let me put a piece of something black underneath this surface. I think a lot of what's showing up on camera is just the reflection off of the gray work surface here. But in person with my own human eyes, and hopefully this helps, yeah, the truss is catching a ton of light. As you know, I am not particularly picky about like what colors I print test things in, but I've been pretty fastidious, except for that very first piece about like all the truss being in this same microcenter, you know, silver. And now I'm really glad that I have been that picky because I think it's taking light really well. Let's see, RG. So we got some kind of sickly yellow amber. Let's see, I've got some nice tasteful cyan. Maybe let's take our exposure down just a hair. Do I not get... Oh, I see. Yeah, there we go. And let's do Valentine's Day pink. There we go. Wow, that... I mean, in all fairness, this overhead camera is showing things a little bit more saturated than they are to my human eye. I guess partly because I have lowered my exposure so significantly. Let's boost that back up. I would, you know, as always, trying to show these things accurately while also being cool as a balancing act. But that looks pretty good. Chris says, what does Chris say? Okay, red 155, green 122. Blue 50. Something like that? To be clear, not a digital process, but something like that. Need some diffusers for the source. Ooh, yeah, are we getting multicolored shadows? Little bit, huh? It's not awful, I would say. Ooh, yeah, there's the tricket. Let's turn this back down again, because it looks cooler when it's darker, right? Ooh, ah. So one thing this makes me wonder, and I think I have the trust to do it, is how many sections of this, maybe let's make this the last question we answer tonight. How far will, say, if I were to illuminate one truss warmer in a solid color and stick another 200 millimeters of truss on this end, will it make it that far? Is it useful to that distance? And looking at this, it kind of seems like no, except we are fairly well blocked by this other truss warmer. So let me grab another 200 millimeter stick of this. We'll bolt it onto the end. We'll see what that looks like. And that'll give me some good stuff to work on this week. So stand by. Turn the exposure back up. Turn some lights back on. Grab truss from the pile of truss. Originally I had planned to put up all of my truss into the micro stage before starting tonight, and I'm glad I didn't, because now we have stuff to experiment with. So here's another section of this. Ooh, I should grab the bolts to assemble it with, of course, which, didn't I grab bolts earlier? Oh, yes, I have M4 hardware just here. Right? Didn't I grab my... Oh, yes. Chris says that's his secret sauce code to make the pixels look like incandescence. Neat. All right, so let's pop this out. And of course, I've turned off auto exposure, so things may look a little bit funkier than they normally do, but for the sake of science, I hope you will forgive me. I'll just thread a couple. So these are, like I said, these are M4 bolts, which is, I know what Cookie designed this system for. You can also assemble these with M6, or not M6, number 6 imperial size bolts or machine screws. Those work just as well. If you are like me, stateside. So I'm just waving this piece of truss in your face as I try to get the... So part of the reason I've been using my number 6 bolts in preference to the large pile of M4 hardware that I have is that I don't have any M4 wing nuts. I just have hex nuts, which are just a little bit fiddly to assemble, even on the workbench here, but even more so in, in situ, as it were. Okay, so there's a 400 millimeter stick of truss, and for reference, the micro stage is 500 millimeters. It is, two 200 millimeter sticks and a 100 millimeter stick. Now, as I looking at this, I wonder, from what we learned now, this 100 millimeter section could also go in the middle, right? If we found that was more advantageous from a truss warming perspective, but here we go. Oh no, Thomas had a skin soldering iron encounter. You make it sound so pleasant. Which I can't imagine that it was. Alrighty here, so let us see here. Let's get our black background back in place. What did I do with that other scrap of matte black foam core from that side project? I've thrown it to the winds, apparently. Well, here, I have a backup solution. This is actually, there's a funny story behind this. We'll use this. This is if it looks like a cut-off piece of doormat, like you wipe your feet on, that's exactly what it is. I'll hide that. I needed a little, so I have a rubber paver that I have under my Prusa as like just a little bit of deadening and like vibration limitation. And it used to be under my Maker Select printer, and I was looking for something to replace the paver when I, moved the nice paver over to the Prusa. And I happened to be at Menards. They no longer carry these rubber pavers that I really like. So I just bought like a cheapy, like $4 doormat, like you'd wipe your feet on, and it was a little bit too big for the shelf. So I cut it off, and I saved the extra bit, not knowing what I would do with it. But tonight it's going to be our matte black background. So let's turn our exposure down again. Let's turn some light off. There we go. And let's just make sure everything works. Yeah. Turn a little more light off just so I can see myself what's happening here. So this is not awful in terms of coverage. I mean, clearly these are not, point sources. These are not like shaped sources. They're not shooting down the truss. They're really spilly, I guess is the word I'm looking for. But I think you can even, I can see with my human being eyes, and I'm hoping you can see on camera, like, there's, I would say this blue covers to here, and I'm seeing just a little hint of it, maybe all the way down here, maybe, 250 millimeters is probably about as far as this would reasonably go. Which, if we were talking about the microstage as it exists, that would be about halfway down. So my impulse, he said, not entirely thinking it through, and also turning some light back on so that the people who are watching him on a stream could actually see it, is that maybe I will rearrange so that this 100 millimeter section is in the center, and we'll do 4 truss warmers per truss. So 1 at the end, 2 at the center facing out, and 1 at the far end. Brooklyn says, have you considered making your own LED boards with stronger LEDs? So I have considered it. Yeah, certainly possible. When I think about that, I think about like some of the boards I have in stock that are like, high power, like 10 watt or 5 watt RGB or RGBW chipped boards, which would be really fun. Having something that would be visible with ambient. Oh, that's fair. Yeah, something that would be, more visible in a normal lighting situation. I could totally see that. So one thing that we could do is like rev up a version of something like the Demilight board, or not even particularly similar, but like that had multiple channels of high current dimming. Right? We could do a board that has 3 or 4 channels of 1 amp dimming. That might be kind of interesting, and then use that to power some truss warmer circuits. Yeah, as you all know from being here, I've been being like a little precious about the small Demilight form factor to keep it inside the lights. But the things that I have learned about the process of the controllers and the programming, the dimming, could certainly be applied to a board that was not so form factor constrained, right? There's no reason to limit a DMX controlled dimming board based on something like the AL8860. This buck boost technology LED dimmer. It doesn't need to be on a board this small, except that I want it to be this small. but there could certainly be an external, a different product, or maybe for something like a truss worm, maybe it's a longer board with multiple points of connection that drives multiple chips in parallel or something like that. Yeah, it's certainly something that has crossed my mind. It's not something that that I'm probably going to pursue next. Although, I didn't think I was going to be thinking about kabuki drops either, so who knows? Also, if anyone out there, wants to try some of this and take it on, Broke Both or others, if you want to do some of that, I would love to see it, showcase it, share it with you, whatever is helpful. Like, I'm an open book. Ooh, little fog machine would be cool. So I've put a little bit of thought into a tiny fog machine. And Chris, only because I know you have done this, I might ask you for a few more details. There are Tiny Fogger, Tiny Fogger is a brand, right? It's out there. They're horribly expensive. There are also small foggers, which are based around commercial vape technology, like, vaporizers. We essentially, right, to make a cloud of glycerin fog, you need a heating element and you need some source of airflow, which for a vape is your lungs, and a coil. And so there are people who have basically modified a small but powerful fan and a vaporizer cartridge into a little mini fog machine. That would be kind of fun. So I might investigate that at some point, because I totally agree that the microstage would look a lot better with fog. Ooh, pond foggers is a good idea, Chris. Yes, and especially because so as you all know, I work at the Science Museum. We have a 70-foot tall tornado exhibit that you can stand in if you want to, and that is all, I think this is okay to say, that is all based on pond foggers. We have something like 40 24-volt, I don't know what wattage they run at, large-sized pond foggers that sit in a pool of sterilized and lightly chlorinated water and stuff underneath a mesh grating. And then there's a whole other apparatus that creates the swirling wind that creates the tornado. But it's all water-based, right? Because you don't want to be spreading glycerin fog throughout the museum for 12 hours a day for years on end. So we have a lot of these spare pond foggers lying around. So if somebody wanted to borrow one to take home and play with, say on a stream, with some nerds and some LEDs, I bet that could happen. Maybe not next week. It's kind of a crazy week. We're opening our Marvel exhibit at the museum, which I am so excited about. It's going to be kind of a crazy week, I'll be totally honest. Like, if there's ever going to be a crazy time at a museum, it's when a new exhibit is opening, for sure. But it is a classy exhibit. I am super stoked. Ooh, and Thomas says smoke units for model trains. It's funny. This science museum I work at also has a model train shop. We have 2 model train techs. And then we don't have smoke, right? For the same reasons we don't have smoke machines in our tornado. They would certainly be the people I would ask about model train smoke machines. That might be kind of fun. Ooh, and Chris, you make a very good point. Yes, I should alert Mary in advance, and I should probably, just for one night only, the smoke detector that is very deliberately mounted right here on the wall next to the 3D printer and me will have to be disabled for just briefly. Maybe moved somewhere else. That sounds like a fun time. A fog night, an atmospherics night. We could have a good time. Maybe not next week. I don't know what next week will be. There may not be a next week. Maybe I'll be exhausted again. Who could say? But I hope to be here next Sunday night with all you good nerds. Thank you as always for all of the good ideas. I often, the nights that I am most excited about when I leave them are nights where we end up in different places from where I thought we would start. Like, I thought we'd maybe be printing a couple of these eye plates and installing them into the microstage and playing with them, and I didn't know what. But instead, we ended up with 2 new designs that I think are both really successful for different reasons, right? One that's good for end of truss, one that's good for mid truss. We wrote a little bit of new software for them. We tested them. We learned a little about how effective they are. Yeah, I'm really jazzed. Thank you all for being here with me on this cool Sunday night. Let's call it there. Thank you so much. Thank you for being here. Thank you for your suggestions and your words. Please stay safe out there. Please be well. Please drink water. Please wear a mask and wash your hands and be good to people. Yeah, I've been reflecting a lot. I think I sort of alluded to this earlier. Like, it really is, it's an incredible privilege to be here, to have 3 hours on a Sunday night to just be able to be like, hey, I have no responsibilities in the world other than being on stream and having fun, and that's really awesome. And I'm especially touched that y'all out there choose to spend that time here with me and with the rest of these fellow good nerds that we're hanging out with. That is really really quite good. So thank you. Be well, and I will see you next week. Thanks, everybody.